So when we're doing probability and the general addition rule, there are a couple big ideas. So basically, a two-way table and a Venn diagram are the same thing. So I'm going to show you in the big ideas what it looks like. So when I draw a Venn diagram, the first thing I want to draw is like a rectangle around it, because that's basically called, when you draw that rectangle, that is your sample space. And in your sample space, you should have all possible outcomes. Okay? So let's just say we have something A and B, right? So we're going to make the two circles. This is A, this is B. So these are the two. Now, in those circles, we'll kind of number the probability. So if there's a overlap, so let's say it happens in both A and B, then we'll give it a 1. We'll just put 1 here. If it just occurs in A but not in B, we'll give it a 2. If it occurs in B but not in A, we'll give it a 3. And let's say over here, usually in the bottom right corner is where you put it, are the ones that don't occur in either one. Okay, I'm just giving them a number. Now, you want to see, how does this relate to a two-way table? So think about a two-way table looks like this. So you want to make a two-way table. You have A, not A, so that means A complement. B, not B. Okay? So, where is, so A and B is found where in the Venn diagram? 1, right? So this is here. A and not B is 2, right? Not A and B is 3. Not A and not B is 4. What is the C for? Okay, that's the complement. But anyways, yeah. So sometimes what they're saying is sometimes you're going to have a Venn diagram and they're going to want a two-way table. Sometimes you're going to have the stuff in the table and they're going to ask you to draw the Venn diagram from the table. So that's how they relate. They're actually the same thing. They're just, one is more visual and one is more, just has it in there. Some people like the two-way tables better. Some people like the Venn diagrams better. Now, the general addition rule, remember, to find the probability of A or B, we're going to say probability of A plus the probability of B minus the probability of A and B. Now, you can remember that one for all of them, because if they're disjoint, think about it, if they're mutually exclusive or disjoint, then you add the two together, then this is going to be 0. It's just going to be minus 0 because they don't overlap at all. So you just remember this formula for all of them, whether they're disjoint or not. So it's the probability of A plus the probability of B minus the probability of A and B. Again, if they are, like I just said, if they're disjoint or mutually exclusive, then the probability of A and B is going to be 0. Because they're not, right? Because it can't happen. So if they're disjoint and mutually exclusive, then you would say the probability of A plus the probability of B minus 0, right? So it would still be that same formula. So what they're showing you is you can still do that same formula whether the two things overlap or not. If they were disjoint and you were drawing a Venn diagram, the Venn diagram would not overlap at all because there would be no time where they both happen. But we're talking about things now that do overlap, so they can happen at the same time. So that means they're not mutually exclusive. They're not disjoint. There is a probability of them occurring together. So that's why we do the probability of A plus the probability of B minus the probability of A and B. An example of that is those red aces. So you add, so the probability of it being an ace or a red card in the deck of cards is the probability of aces, which is 4 out of 52, plus the probability of reds, which is 26 out of 52, minus the probability of it being an ace and red, so that's minus 2 out of 52. And so when you do that, you take away where it overlaps, where you have those red aces. All right, so we're going to go down to an example problem here. About a specific problem. So this says, what is the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not. So they just asked them, have you been a high school graduate or not? And then, are you a homeowner or not? So there's two questions. So in a two-way table, typically, you're answering two questions. That's why they call it a two-way table. The two-way table displays the data. Suppose we choose a member of the sample at random. We want to define these events. There's two events here. The first event is G, that is the person is a high school graduate, and then H we define as the person is a homeowner. So explain in plain language what the probability of G complement means and find the probability. So G complement means the probability that the person is what?
Not a high school graduate.
Right. The probability that the person is not a high school graduate. That's what that means. And then find that probability. So the probability that a person's not a high school graduate. Well, first, to kind of do these, we need to total all this stuff up. So high school graduates, we have 310. Not high school graduates, we have 190, which gives us 500 total. Homeowners, we have 340, and not homeowners, we have 160. So when you get a table like that, when you get a two-way table, it'll be nice you want to total those up first, because you're going to need that when you work through this. So the probability that the person is not a high school graduate, so not a high school graduate is 190 out of 500. Which equals 0.38. So that'd be about 38%. The decimal is fine in these. So you want the fraction and the decimal. The fraction and the decimal. Anytime we're doing probability, fraction and the decimal. Okay? Because they have to see where it came from. You got to know where that 0.38 came from in these. So it's kind of like just showing your work, basically. In statistics, you can't just throw out a number. You got to show where you got the statistics from. So 2, explain why the probability of G or H is not equal to the probability of G plus the probability of H, and then find the probability of G or H. So why is it not equal to just adding the two together? But why not? Why do you have to subtract?
Because it overlaps.
What?
Well, they're not disjointed.
Okay, so in this case, there are people that are what?
A high school graduate and a homeowner?
Yes. So because there are people that are in both. There are people that are high school graduates and homeowners. So that's why you can't just add the two together, like you said, because it overlaps. Because there's people that are in both groups. They were mutually exclusive, if they were disjoint, they didn't overlap. If people couldn't be in both, then we could just add them together. So now it says find the probability of G or H. So we're going to do high school graduate. So we're going to say probability of G or H equals. So we're going to say high school graduate. There are 310 high school graduates plus homeowners, there are 340 homeowners, minus the ones that are high school graduates and homeowners. That is 221. Okay? So 310 plus 340 minus 221 And all that's going to be divided by 500, right? Because that's our total number of people. So 310 plus 340 minus 221 gives us 429 out of 500. And then we want to get that decimal. The 429 out of 500 is I'll probably go to 3 decimal places there. So 0.858. That's what I got. And that is actually as far as it goes. So 0.858, so that's about 85.8%. Now, you should notice if you forget to do this, if you forget to add them together and then subtract both, you would get 650 out of 500, which is impossible. You get a number bigger than 1. So it'd be more than 100%. So that can't happen. Right? So you would hopefully understand, oh, that can't happen, I've messed up. Okay? So lastly, we want to make a Venn diagram to display this. So a Venn diagram, we've got our rectangle. We know that these do overlap. So we've got the overlap here. We've got G for graduate. We've got H for homeowner. Okay? Now, we can, there's a lot of different things we could do here. So we could just put in the numbers. We could have put in the probabilities. For today, we'll just put in the numbers. So how many are graduates and homeowners in the middle? How many are graduates and homeowners? 221. Now, if you wanted the decimal, yeah, you could do 221 divided by 500, but we don't have to do that. Then we want to say how many are graduates but not homeowners. So they would be over here. They're graduates, but they're not homeowners.
89.
That's 89. How many are homeowners but not graduates? 119. And then if you notice in the very bottom, you're going to have people that aren't in either group. So they're not a high school graduate and they're not a homeowner. That's your 71. Okay. Now, sometimes you can put these as numbers. Sometimes we put these as probabilities. It just depends what the question's asking. But you can easily find those. If you add all of those up, you should get 500, right? Because there's 500 total in this sample. So there's 500 people. So when you add if you do a Venn diagram correctly, it should add up to give you your total amount at the end. So question number 4, that's not on the board, but I can read it. Write the event is not a high school graduate, but is a homeowner, and find the probability. So this is the probability that they're not a high school graduate, so the complement of being a graduate, and they are a homeowner. So they're not a high school graduate, but they are a homeowner. So where is that number? That's in there. So that is not a high school graduate, but is a homeowner. So that's 119 out of 500, which is going to give us 0.238. So almost 24% are not high school graduates, but they are homeowners. So we could ask tons of questions with this. We could say how many are graduates and homeowners, how many are graduates but not homeowners, how many are neither, what percent, and you should be able to, basically you took a two-way table and made it into a Venn diagram. You should be able to take like a paragraph of them just saying stuff and make it into a Venn diagram. The probabilities, there's many different, so like we could take these questions and we could ask all kinds of different stuff from the same scenario. Tomorrow, about half of the class will be drawing the Venn diagrams and answering questions from a Chapter 5 worksheet on the addition rule and Venn diagrams. And that comes from all the stuff we've learned today. Okay, so that'll be your Friday work coming up.